Hello class, this is Mr. McAllen, and I got a few emails from people, and they were asking me if I could review kind of what we did in class today with the system of radians. So I'm just going to walk us through, for the benefit of everybody who maybe wasn't there today, what we did in class. We first started off talking about the degree system. And the degree system is a system where we discussed the Babylonians, and we discussed how many societies were maybe fixed on the fact that for every day, you know, there are 360 days, or 365 days in a year. So a simplification may have been that for every day we pass through 1 degree. So in that system, we can almost imagine that for our one revolution, we would have 1 degree per day revolved. So then we were talking about if you were living on another planet, and let's say that you had, instead of 360 degrees or 360 days, you had 700 or 800 days. Your degree system may be completely different for the circles that you have, and that would create a contradiction. For example, if you were living on Mars, I'm just going to throw out a number. I don't know the exact number of days, but let's say there were 700 days on Mars, then you would say that 1 degree for your circles on Mars would be, you would have actually 700 degrees for a circle. And this creates a problem when you're working on with math and trigonometry between the two planets. So let's consider something more universal, something that could be used no matter where you are, and that's a radian. And what we did in class was we first had kids, take a piece of string and cut it to a certain length, and then they generated a circle from that. So let me just get a circle template here, and I'll make a circle that hopefully works with that. And that looks a little big, so let's see. So we draw. So for this circle with that length of radius, what we noticed in class was that that this length, this radius, when we cut the radius and we went around the circle, we noticed that it's about 6 radiuses around the circle, a little bit more than 6 radiuses or radii. And what you can say is that if you consider each radii to be 1 radian, then approximately for every circle, 1 full rotation would equal 6 radians. Now this isn't exact. This is actually, what I'm using is I'm helping us kind of derive the formula for circumference, which says the circumference around a circle is 2 pi times the radius. What that means is we have approximately, if you look at the number 2 pi, that's approximately 6 radiuses for 1 full circumference. And that's where we get the idea of radians, because 1 radian is the equivalent of 1 arc length. That would be the length of a radius. So when we look at this circle here, instead of calling 360 degrees, we can mark out our angular measurement by thinking of radians, in terms of having 6 radians as you go around. So what we want to do is use radians instead of degrees to understand where we are on the circle. So in this circle I'm drawing over here, I'm going to just draw, as I did in class, where we are when we're at the quadrant lines. For instance, we start out at 0, and when we go halfway around, we're at around 3 radians. We're at 4.5 at the bottom, and we're at 1.5 radians at the top. So this is not exact, because the real value would be pi over 2, and I told everybody in class to just assume that pi is equal to 3, just to help us kind of quickly move around the circle to know where we would be. This one here would be 3 pi over 2, And if you substitute a 3 for pi, then you'll find out that you're at about 4.5 radians for that angle location. So let's take a look at one of our homework problems that we had for today. So we'll look at number 1. I'll sample number 1 with you, and I'm just going to cut and paste these problems onto another sheet, and we'll work through them so you get an idea how to do this homework tonight. So it says to sketch a unit circle, and that just means a circle of radius 1. So I have a unit circle, and I'm just going to mark on the unit circle my little markers to tell me where I'm at. I'm at 0 here, 1.5 radians here, 3 radians here, and 4.5 radians here. And when I finally get around again, this will be 6 radians, and then this could be 12, and so on and so forth. But for now, let's just work with what we have here. So I'm going to use, instead of pi, I'm going to consider that to be 3, because pi is approximately 3. So I'm going to go to the radian location of 3/4, and that would be this location right here, and I'm going to label that A. For B, that's 3 times 3, because pi will be 3, over 2, and that'll be 9/2, or 4.5, and that'll put me right here. Then I look at the next one, and that says 3 times 3 divided by 4. That's 9 over 4, which is 2.25. So that's going to be 2.25 will probably be about right here. So that'll be point C. And then D is, that's easy, that's 3 radians. And E is 11 times 3, that's 33 over 4. So you got to do a little division here. That's going to be 8 1/4, 8.25. So here we go, we're going to go around the circle once. So that'll put us at 6, and then this will be at 7.5. And then 7.5, this will be 9. So I probably am going to end up here at C again, somewhere around there. That would be point E. And then finally F is 17 times 3, because pi is 3, over 4, or approximately 3. And that's going to be 51 over 4. So what that is equal to is, that's going to be 12 3/4, or 12.75. So I'm going to come around the circle twice. That's once, twice. I'm at 12, and then I'm going to go to 0.75. So this will be point F. So hopefully this helps you as far as recognizing where to place your radian amount on the unit circle. And then we have another type of problem, which looks like number 5. So what we'll do is, on number 5, I'll just draw a circle, and I'll name some dots. So I've got my circle, and I'm going to just name some point locations. So I'll say maybe this is A, and I'll call this B, call this C, maybe D, and I'll call this E. So I would want to say in the homework, all you have to do is for point A, you would have to give the real number for that value. So you know that's between 0 and 1.5 radians. I would say that's probably 0.5 radians, because this would be 0.75. For point B, you would say it's past 1.5, but it's not quite at 3 radians. So I would say that's about 2.25 radians. Point C is at, let's say, 4 radians. Point D is at, let's say, 5.5 radians. Someone could argue that it's at 5 radians. That's fine with me, because it puts you in the right quadrant. And point E would be at 1.5 radians. So I hope this little bit of a review of what we did today kind of helps refresh your memory. And remember that as far as we're concerned, for just simple use, as you go around a full circle in terms of degrees, it's 360 degrees. But as you use radians, it's just a more simplified system, where instead of having 360 degrees around, they've cut the system up into approximately 6 even parts. So 360 degrees maybe for one circle for degrees, but in terms of radians, you have 6.28 radians for the distance around, or the angular distance around a unit circle. Take care, and I look forward to hearing your feedback tomorrow.